Hi everyone, my name is Julie Pansteris.
And my name's Rachel Roberts, and we'll be presenting on Vomo, a voice monitoring app for smartphones. Julie and I are both seniors studying speech, language, and hearing sciences. We are participating in the Voice Swallowing Mechanics Lab on the Vomo project for our honors capstone. We would like to thank the VSM Lab and give a special thanks to Dr. Victoria McKenna and Kelly Carrero for assisting us on this presentation, along with our fellow lab members and UC Health collaborators. We also want to note that this work is supported by the University Research Council faculty grant from the University of Cincinnati. People with chronic voice issues or dysphonia, such as someone with Parkinson's or vocal fold cancer, often require frequent visits to their physician's office to monitor their voice deterioration or progress. The purpose of VSM's VOMO study is to develop a smartphone app that can help these patients record their voices from home. The goal of the present study was to understand how holding a phone in various positions can impact the accuracy of vocal acoustic measures. So far, we have recruited 7 participants with healthy and 17 patients with disordered voices. Each participant was asked to follow a 3-step protocol, including saying "ah" for 5 seconds, holding "ah" for as long as possible, and reading 2 sentences from the Rainbow Passage, which is a standardized speech sample. As the patients followed the protocol, we recorded their voices on their smartphones in various positions. The 4 phone positions are shown here, but we are most interested in the quality of natural distance tilted because we intend patients to read prompts off their phone as they record on the app. We also recorded the participant's voice on a professional microphone, acting as a clinical comparison to the smartphone recordings. Next, the acoustic measures were compared between all recordings.
The processing of acoustic data was done in 3 steps. First is pre-processing, where the recordings from both the phone and handheld were extracted and organized by phone configuration and task. After that, the acoustic analysis program, PRAT, was used for extracting parameters. Finally, the quality of the signal between the handheld and phone was compared. This was done using various statistical models, including mixed general linear models, that tested for significance using comparisons across task, recording device, and recording position. When needed, the Tukey method was used to determine where specific differences were. Using these models and tests, our aim was to address research questions specific to pitch, harmonics to noise ratio, and duration. One of our primary research questions is concerned with pitch and if there is a variation between the apparatus used, which would be the phone versus handheld. The 4 phone holding positions and tasks, which were ah, maximum phonation time, and Rainbow Passage. Our findings show a statistically significantly lower pitch in the Rainbow Passage with an average of 154 Hz compared to the ah and maximum phonation time tasks. These results were expected because running speech usually results in a lower pitch. This measure is also not of concern because of the similarity in results between the phone and handheld, showing that the primary factor was running speech versus not. The second research question addressed through acoustic analysis is whether duration, which is time of phonation measured in seconds, varies across apparatus and recording types. Analyses concluded that natural distance tilted and measured distance are significantly different. We can attribute this difference to data being pulled from participants saying these tasks at different times. The results confirm the variability in human speech rather than any difference in recording apparatus or phone configuration. Our final research question was specific to harmonics to noise ratio and if there are variations by apparatus, position, and task. Metric is concerned with the ratio between periodic and non-periodic components of speech sound. For example, an individual with a hoarse vocal quality will have a lower harmonics to noise ratio. There was a statistically significant interaction between apparatus and task when considering its effect on harmonics to noise ratio, in which the phone recordings had lower values. Although we have run data for 24 participants, our overall goal is to recruit 100 individuals. We plan to further investigate acoustic measures and eventually apply these findings to our finalized design of the VOMO app. This concludes our presentation. Thank you so much for your time.